Here's a common question, type of question that sort of investigates your understanding of what a mole number is. And you could look it up. I use the approximation of a mole as being 6.022 times 10 to the 23. And you can look it up to more digits if you need that accuracy or if you just want to have that accuracy. And the mole number is a counting number. It's like a dozen. So I'll do this question for a dozen, and it'll be obvious how to do it. And then we'll do it again for a mole, and it'll be pretty obvious how to do it again. So let's give it a try. So doing unit conversion, I start with 1.2 kilograms per soda. Let me grab a better line there. And I'm going to multiply it by 12 sodas per dozen. And that will get rid of these very poorly drawn units of soda. So I'm left with kilograms per dozen, and I want to get grams per dozen, because that's what it's asking. What is the mass of 1 dozen sodas in grams? So I need to multiply by the conversion factor for kilograms and grams. I could look this up. You could look it up. The prefix kilo means 1,000. So 1,000 grams equals 1 kilogram. And what that means is that I can write a conversion factor of 1 kilogram per 1,000 grams. And that's not going to help me, actually. Got to get rid of that. I need grams on top. I need kilograms on the bottom to get rid of these kilograms on top that I don't want anymore. So actually, I'm going to have to flip it over. I'm going to do 1,000 grams per 1 kilogram. And if I cancel the units from top and bottom, I will get rid of these kilograms. And I'll have 1,000 on top times 1.2. The units are grams. On the bottom, I just have 1 times 1 times 1. And the units are dozen. So yeah, this is 1.2 times 12 times 1,000 over 1 times 1 times 1. So this gives me a value of 14400 grams per dozen. And if I had to redo this in sig figs, I'd look at the original number I had, which was 1.2 kilograms. So that's 2 sig figs. 12 for a dozen is actually infinitely many sig figs because it's defined as 12. A dozen is 12.0000 forever. So that's not going to limit my sig figs. And then there's 1,000 grams per kilogram, and again, that's the definition. So there's infinitely many zeros after the decimal point in this number, even though I'm not writing them. So there's exactly 1,000. So that's like 1,000.0000 forever, infinite sig figs. So I'm getting limited here by the 1.2 sig figs that I started with. So I want to end up having a 2 sig fig number. I'm going to have to use scientific notation to help me out here. So I'm going to grab this decimal point and move it 1, 2, 3, 4 places over. 1, 2, 3, 4 places over. So I'll get 1.44. I'm going to round it to 2 sig figs, so it's just 1.4 times 10 to the 4th grams per dozen. All right, so that's a dozen. It's not going to scare anybody away. It's a pretty common unit or counting number everybody uses. What about moles? Okay, so really it's mostly the same problem. I still start with 1.2 kilograms per soda. But now I'm going to use the counting number of a mole, that a mole is 6.022 times 10 to the 23. And I have to write soda. So that's how many sodas would be in a mole of soda. Sorry that it's in a separate line. And that's that many sodas per 1 mole of soda. So really the same units kind of cancel out, or similar units cancel out. So I end up getting rid of sodas. I have moles left on the bottom. My kilograms go away, right? And I'm left with grams on top, moles on the bottom. And that's what I want. I want to get grams per mole. So like if there's a mole of sodas, I want to know how many grams that is. That's what the question's asking. Again, I'm only limited to 2 sig figs because there is just 2 sig figs in the original mass. I could take the mole number out many, many decimal places. It's been measured, I guess, defined pretty accurately. And I also have infinite sig figs in this grams. So I just have to multiply these things together and then divide by these numbers in the bottom. When I use a calculator, I end up getting 7.23 times 10 to the 26 grams per mole. If I have to round this to 2 sig figs, what I would do is I would get rid of this 3. So I'm just rounded it to 2. Since that 3 is less than 5, I know to round down. So I round to 7.2 instead of rounding up to 7.3. And that's how you do this problem. But